Okay, hello to all of my fantastic 307 summer students. I hope this video finds you well. So in this video, I'm going to go through an example of a factorial designs exercise. And this exercise is identical to what you guys will be asked to do in the lab assignment, the factorial designs lab. So hopefully if you watch this video, you'll be able to do your lab assignment and you'll know exactly what the procedure is. Okay, so let's go ahead and begin by looking at this scenario. Okay, so let's just read it out loud together. A researcher hypothesizes that rats raised in an enriched environment will have more neural growth compared to rats raised in isolation. It is also hypothesized that this effect will be more pronounced in premature rats than full-term rats. Okay? So right away, it should become apparent to you that what we have here is we have a 2 by 2 factorial design. Okay? And this particular notation, okay, we know from this notation that we're dealing with two independent variables, right? Because there are two numbers here, okay? And we know that each individual independent variable has two levels because the number is 2, right? So going off of that, okay, let's look at what our independent variables are, okay? So for IV1, we have birth, okay? And our levels are premature versus full term. And for IV2, we have environment, and our levels are enriched versus isolated, okay? And then the values here in the cell means, okay, that's our DV, which is neural growth, okay? And I apologize for my atrocious handwriting, okay? So we have IV1 is birth, premature versus full term. IV2 is environment that the rats are raised in, and that's enriched versus isolated, okay? And then our dependent variable, our continuous dependent variable is amount of neural growth, okay? So essentially in this classic experiment, they had some rats that were raised in a cage by themselves with nothing but sustenance, okay? So they had food and water and that was pretty much it, compared to an enriched environment where they actually had, toys to play with, things to climb on. They had a little exercise wheel, and they also had access to other rats. So they were raised with other rats. And for those of you who might not know this, the classic lab rat, the species of lab rat, also known as a Norwegian rat, is an intensely social creature. So they crave social interaction, and they actually have a fairly complex social hierarchy as well. So one would expect that brain development would be facilitated by allowing for these complex social interactions. Okay, all right. So now that we have a sense of what our independent variables and dependent variables are, let's go ahead and start tackling the questions that we're tasked with answering here. Okay, and we'll start with part A. Okay, so part A states, state whether the results indicate main effects of either variable. Okay, so just like when we were talking about the ANOVA, okay, a main effect is basically treating this experiment as though it had a single independent variable. Okay, so for example, if we wanted to look at the effect of environment, okay, what we would do is we would look at the means for environment collapsed across both age groups. Okay, so ignoring age completely, okay, does the mean neural growth for enriched differ from the mean neural growth for isolated, right? Okay, well, let's take a look. Okay, so to find our main effects, we're going to calculate what are known as marginal means. Okay, and marginal means are just called marginal because they're placed in the margins of this table, right? So remember, we're collapsing across both levels of age to see if the overall mean of enriched differs from the overall mean of isolated. Okay, so if we were to take an average of these two values, 40 and 30, we would get 70. Okay, and we would divide by the number of values, which is 2, and that would give us a mean neural growth of 35 in the enriched condition. Okay, and we would do the same thing for isolated. Okay, so 25 plus 25 is 50, divided by 2 is 25. Okay, so right here we see that there's a 10-point difference. And for the purpose of this exercise, let's assume that a 10-point difference is significant. Okay, so for the first question, okay, we know that we have a significant main effect of environment. And now for part B, we need to state what that main effect is by looking at the direction. So we might say something like, the overall mean neural growth for the enriched condition was 35 compared to the overall mean in the isolated condition, which was 25. Okay, so therefore, in support of the researchers' hypothesis, overall, there was more neural growth in the enriched condition than the isolated condition. Okay, so overall, in support of the researchers' hypothesis, there was more neural growth in the enriched condition than the isolated condition. Okay, and now we need to look at our other IV, which is birth, right? And again, we need to collapse across both levels of environment, right? So we're treating age here as a single independent variable. Okay, so just like we did for the enriched versus isolated, now we're going to collapse across both levels of environment and get an average for the premature condition, which is 32.5, okay, or 65 divided by 2, okay, versus 27.5, or 30 plus 25 is 55 divided by 2, okay? So here we see that collapsed across both levels of environment, okay, does the mean neural growth for premature rats differ from the mean overall growth for full-term rats, right? And we see that indeed 32.5 is larger than 27.5. However, if we implicate our rule of a 10% difference being significant, okay, that's about a 5% difference. So it's unlikely that this main effect is significant. So we would say something like, the overall mean neural growth for premature rats was 32.5 compared to the overall neural growth for full-term rats, which was 27.5. Okay. However, this difference did not reach significance. Okay. Okay, so now we have stated our main effects for both variables. Okay, so our next task is going to be to see if there's a significant interaction. Okay, and the procedure as far as trying to see if there's an interaction is we're going to look at the simple main effects. Okay, so we're basically going to look at the different levels of one independent variable for a single level of another independent variable. Okay, so what do I mean by that? Okay, well, let's start by looking at the difference between the two levels of environment just for premature rats. Okay, so we're just looking at premature rats here, and this is our main difference. Okay, so for premature rats, there is a 15% difference. Okay, compared to, now we're looking at the full term. Oh, that's obnoxious. Let me get another color. Okay. Now we're looking at the full term. Okay. And we see that there is a 5% difference. Okay. So in both cases, right, there is more neural growth in the enriched environment rats. Okay, but this difference is greater for premature rats than for full-term rats, right? So just like we did for the factorial ANOVA, right, we would say, okay, that for both premature and full-term rats, the enriched environment led to more neural growth than the isolated environment. However, this difference was far greater in the premature condition, okay, than the full-term condition. Okay, and so the last thing we have to do is we want to graph this to demonstrate the interaction. Okay, so how are we going to go about doing that? Well, basically, we are going to graph the cell means. So we are going to graph everything in this box. Okay, and again, we're going to use a line graph. Okay, but we can also use a bar graph if we wanted to. So maybe we'll do both just to illustrate that. Okay, but the first thing we need to do is we need to label our X and Y axis. Okay, so what we're going to do is in the Y axis, okay, we are going to label our dependent variable. So our DV is neural growth. Okay. And as far as axes, right, we range from 25 to 30. Okay. So let's just do differences in terms of fives. Okay. So we'll do maybe 20 here. I need more room. So 20, 25, 30, 35, 40. Okay. And then we'll just add a little squiggly here to indicate that we're not starting from 0. Okay. So again, I'm running out of space here, but this, you would want to label this as our DV, which is neural, oops. Neural growth. Okay. And then on our y-axis, okay, we're going to indicate IV environment. Okay. And we're going to have enriched versus isolated. And then we're going to have in our legend, so in the actual lines themselves, okay, we're going to have a red line equal premature and a black line indicate full term. Okay, so now all we have to do is we have to plot our cell needs. Okay, so for enriched, okay, the we'll start with premature, right? So for premature, the enriched value was 40. Okay. And the isolated value was 25. Okay. And then, so we need to plot this in red. Okay. So now we need to plot the line for full term. So for full term rats, the enriched value was 30. And the isolated value was 25. Okay. So then we are going to, oops. Oops. Okay. So then we are going to plot the second line. Okay. So it's a little bit hard to see there, but those lines are not parallel to each other, right? They're slightly perpendicular. So that would suggest, like I said, that there's an interaction. But let's go ahead and plot this as a bar graph. Okay. So again, our x-axis and y-axis are going to stay the same. And the red bars are going to indicate premature rats, and black bars are going to indicate full-term rats. Okay, so let's go ahead and plot the premature rats, or let's go ahead and plot the enriched condition first. Okay, so for the enriched condition, for premature rats, okay, we have 40. Okay, so that 40 is up here. Okay, so the premature rats, 40. And the full-term rats are 30. All right. And then in the isolated group, we have premature at 25. Okay. And full term at 25 also. Okay. So again, the difference between enriched and isolated for premature rats is much more significant, okay? If we look at the red bars, right? For premature rats, it's 40 versus 25, okay? Compared to the full-term rats, where it's 30 versus 25, okay? So again, we see the same thing, right? That comparing across the two, the differences for premature rats are much more significant than for full-term rats, okay? So let's try one more thing, okay? Just so you can see it a slightly different way. Let's go ahead and put premature versus full term, okay, on the x-axis. Okay, and then the colors are going to differ between enriched and isolated, okay? So the black will indicate isolated, and the red will indicate enriched, okay? So let's go ahead and look at it this way, okay? So for premature rats, The enriched, okay, was 40. And the isolated was 25. And then for full-term rats, the enriched was 30. And the isolated was 25. Okay. So here is probably where it's most apparent, right? So the difference, right, for the preterm rats, if we look at the space between the bars, okay, is much bigger than the difference for full-term rats. Okay, so that's just a couple of different ways you can graph to illustrate an interaction, right? And again, the interaction is simply the fact that the difference for premature rats is a 15% difference in neural growth compared to full-term rats, where the difference is only 5. Okay, so the effect of environment, or enriched versus isolated, depends upon the birth of the rats, whether they're premature or full term. Okay, so hopefully this makes sense. As always, feel free to email me or text me if you have questions. And I hope you guys have a great day, and I look forward to seeing you in my next video.